So we are HydraChain, and as our name suggests, we are dealing with water and integrating in the blockchain component to solve our problems. So we identified a problem that is very obvious in across Africa, and since we are working within here, so northern region or the northern part of Ghana, and these problems were the seasonal droughts and broken boreholes, which leaves communities with no water, the limited monitoring and delay repairs, which increase the breakdown time, and women working long distances for water, and waterborne diseases affecting our livelihoods. So we did some on-ground researches, and then the people suggested to us some solutions which we tried to integrate in our broader solution. So they were reporting on reporting. The people preferred simple alert tools like SMS or USSD to report faults, and they suggested frequent diagnosis of their water bodies. And the technicians also preferred early warning alerts. So, but to make you understand the scale of this crisis, we try to bring in a problem story. So last month in the Savulgu and Tolong districts, wells and boreholes began dispensing cloudy water. On the first day, the communities noticed, but they didn't take it serious. By the seventh day, the children started getting cholera. By the 14th day, someone had to travel about 30 kilometers to the district office to report, but nothing was done until the 21st day when a district inspector was sent. So the problem was, the technician was dispatched by the 45th day, a very long period there. But then the problem failed by the 60th day, and we are in the 120th day, and the boreholes are still closed. So the community still use the river water, because why would you want to waste your energy drilling out water from a borehole when you could just fetch that same cloudy water from a nearby river? So we did some further research. So the impact of this was that 23 children were hospitalized. There were 1,000 hours that were lost to fetching water from alternative sources like the river we mentioned earlier. 4,500 cedis was lost in productivity and healthcare costs. And women walked an average of 3.7 miles every day just to access water. This happens thousands of times across rural Africa, and half of the hospital beds are filled with patients battling waterborne diseases. On our further research, we came to realize that there's 30 to 40% of rural water points are non-functional. 3 to 6 months, they take 3 to 6 months average repair time, which is very long. And 40 to 60% of these repair budgets do not even reach the communities. The donor-built systems fail 2 to 3 years post-exit. So the donors come in to fix the problem, but after they leave, their solutions are not sustainable. So they fail just within 2 to 3 years. So we actually diagnosed it. And then we grouped those problems into four categories. There's no early warning. There's an accountability vacuum there. The communities are excluded, and there's no sustainability. The technicians claim the work is done, but is it done? No one can verify. So the maintenance budgets do not even reach the communities. So on a larger scale, to make you further understand the impact of this crisis, 2.2 billion people lack access to safe drinking water, and 1 in 3 children live in water scarcity, which, if you ask me, is very bad and should be tackled. So, but what are we proposing? Our solutions are in 3 layers. We have the monitoring layer, the maintenance layer, and the sustenance layer. So, but we have to make you understand how it works. Our solution combines affordable IoT sensors with mobile-first technology to provide real-time monitoring of water quality and sanitation infrastructure across underserved communities. So we want to break it down further. And on our monitoring layer, which is the technology stack, and we like to address it as the one that fits the reality. We have smart water points that keep everything on track. So these IoT sensors in the water bodies, they measure the turbidity of the water, the pH of the water, the flow of the water, and the water level. So they are solar-powered sensors that take readings every 15 minutes and transmitted via LoRaWAN. And they detect the turbidity spikes, pump failures, source depletion, and chemical imbalance. This data can either be collected via the sensors or through mobile submissions, which are just simple manual logins. The platform aggregates the data via blockchain into simple dashboards, and these are transmitted as automated alerts to the technicians, and communities and stakeholders can actually see transparent information. So this issue of trust and accountability is handled there. So explaining this one. So I want to explain this further. When the IoT sensors detect the issues that are wrong with the water bodies, and then they automatically uploaded onto the blockchain networks. So the technicians are they are notified, like they suggested earlier. So they are notified and they step in to fix the issue. But then after they take the contract, we want to solve that issue of no accountability. So after they are done, the IoT sensors detect if they say they are done with the work. So the IoT sensors detect the what they try to check in the water bodies to see whether this is actually solved. If it is, then the payment is done automatically. So we have solved all of those issues just in one. And because we wanted to include in the community, so it will not be something that is just in vague. So we try to include in the community user experience, which is the inclusion aspect. So anyone with a phone can access it. They can check the water status, report water issues, and vote on issues. And actually, this one is part of the tier 3, the check water wash tokens. So a grandma with a simple phone has the same power as a teenager with a smartphone. We are not asking them to understand blockchain or understand technology that is complex. We are just telling them to understand USSD and how to report their issues. And it's something that is actually practicable, because in these same rural areas, this issue of what's the name? Sorry. In these same rural areas, there are we are not asking them to understand blockchain, but then if you realize something, there's this lottery that is so common there, and they do the same thing via USSD. So these same people who can do those lotteries with the USSD, they can actually stick and check in all of these things via the same USSD. So it's something they're already conversant with. It's not something that we are feeding them complex they can't do. Okay, so back to our blockchain components. Why are we using blockchain? The blockchain component saves the trust issues, and it's not just cool tech, it's the real deal. Nobody controls the records. Money can't move without verification, like I explained earlier. Payments are automated and verifiable, and communities govern transparently. So everything is visible. You can see everything that is happening. And like I said earlier about projects being set up, but after the donors leave, it breaks down within 2 to 3 years. We want to tackle it. So we came up with the regenerative model, which is part of the sustenance and sustenance, our sustainability aspect. So we want this data that the IoT sensors are taking, after they are verified, they can generate revenue through NFTs. And then with that money that is gained, more infrastructure can be built, and then we get better water because we get more devices to check this water and solve everything. So when we get better water, there's more data and we get more value. So it's a cycle that just goes on. It's not something that starts and breaks halfway. So to further explain our NFTs, the NFTs are able to give us the provenance. So they help us verify the origin of the data. No one can just come out and, like in a certain community, you can't just say, oh, this data point has these issues, and so we need, or this is the data we are presenting. You can actually verify where it's coming from. And then we get royalties when the data are sold or being used. We can actually control or access the data. And the revenue is split. We can get 50% for the community, 30% for revenue, and 20% for platform. The NFTs can be sold to researchers, NGOs, and communities that need water data, creating a system that feeds back into maintenance. Okay, so we also did some critical examinations, some before and after, before we come in with our Messiah solutions, and after we implement them. So before, detection could take about a few weeks, but after being implemented, they can take us just a short while, as a few minutes. And the downtime was about some months, and now they can take just days. The testing was annual, but now it's every 15 days. So our IoT sensors are supposed to be taking data within every 15 minutes.
1 minute.
And testing is annual. Okay. So the strategic partnerships, we are trying to partner with our governments. We are not replacing them. And the governments in here, they serve as partners. So we can give them the data. There's more capacity building and all that stuff. So it feeds back into the maintenance and sustainability. And for the future roadmap, we plan to expand beyond just northern communities, launch a water token governance model, secure a public budget integration with the government if they see that the project is something that is good and implementable, and develop a decentralized data model. And this is a map to show the expected impact with the aftermath of implementation. So I want to end with a quote from Thomas Fuller. We never know the weight of water till the wells run dry. So this has to be tackled. Thank you.
Wow.
Time is up, but you want to demonstrate
investment. You will invest in this. Any demo, I'll give you 1 minute or 2.
Yeah. I think they have some demo here.
All that you said is that the narratives, one the practicality. But although that was great.
Okay.
Real time watermark.
Okay. Please, this is our demo, and this is our homepage. So this is the site that will enhance our society, making it easier for them to access. So here it talks about the IoT sensor network, interactive mapping, instant alert, then community reporting, and data analytical and offline first design. So then we go to the dashboard too. Okay. Yeah, this is the Tamale map, the water monitoring map. It indicates the location. So this also makes it easier for the developer, the society. If there's a problem that occurs, you can simply get the location of where you have to face a problem. So this is Tamale here. Then we also have Jaka Yele, Tishogu, and we also have the Moshuzungu and other stuff. So
Yeah.
So, and this is the impact the dashboard that talks about the disease reduction, response time improvement, and the cost saving. Then we also have the active monitoring point. It indicates the problems so that have been solved in the society. Then we also have the critical alert. That's when they send the problem to them, they can get access to it and try and manage the problem with them. Then this is also the report where they can also give their location, the issue type, and the description, the problem, then their contact also, so that you can reach out to them. Oh God. Then it talks about actually the company, what they do, and their mission. Yeah, everything about this. Yeah. Then the team, what they use to develop the design, front end, back end, the IT hardware, then the UI or UX designer, data analysis, and the project manager too. Then it also talks about our value.
Okay.
What's the purpose of it?
Yeah.
Thank you.
Okay.
That's all.